So now this video discusses how we can be able to incite differentiation rules. Let's say we have a case where we have, let's say, f of 5. Let's say it is given us, there should be 1, and f of, let's say, a 5 prime. Let's say f of 5 prime is given as, let's say, 6, and let's say we have g of 5 is given as, let's say, should be -3, and we have g of 5 prime, and let's say it is given as 2. Now determine the following values. Let's say we have a, we have f of, should be fg, actually there should be prime, let's say of 5, should be of 5, by the way, should be of 5. Now how should we have the value corresponding to this one? So using the principles of the combination functions, you should have to understand that having this case, it means the two functions f4, actually the two functions that is of f as well as the g are having the same input as 5. So which means in that case this is the same as having it as f of 5 prime times g of 5 prime. So that's what it means there. Then we'll have to substitute what is f of 5 prime. We have it as, we have it as 6 times, and what is g of 5 prime, we have it as, and that is given as 2. So in this case we'll have it as 12. So that is the solution on how you can have that one. How about, let's say, b? We have, now the question part b says that we should have the value, let's say, f actually stroke g of should be a prime of 5. So what is this case? Now in this case this is the same as having it as f of 5, a prime divided by g of, that should be 5 prime. So what is the value of 5, f of 5 prime? We have it as, that is being given as, by the way, now what is f of 5 prime? We have it as 1 divided by what is g of 5 prime? We have it as, that should be given as 2. So this is the solution in that case. Now how about, let's say, a question part c. Let's say we have it as this. Let's say we have, and that should be g a stroke f of 5 should be prime. So in this case principle remains the same. This is the same as g of 5 prime divided by f of 5 prime. So that is how you should have to get it up. And how about if we have the following information, how we can be able to incite the differentiation rules? Let's say we have, should be f of 4 is given as, let's say, 2, and let's say we have g of 4, let's say it is given as 5, and let's say we have f of, should be 4 prime is given as, let's say, 6, and also g of 4 prime is now being given as, let's say, should be given as -3. Now find the value of, let's say, h of 4 prime, and for the following, find the value of h of 4 prime, that is for the following. Let's say a, we have h of x, we have h of x, that is being given as, we have 3x, that should be this, 3x should be 3f of x, and plus should be 8 and that of g of x, 8 g of x. Now how should we have h of 4 prime? In this case, first thing, we're going to differentiate h of x. That will be given as h of x prime. Let me use this. Should be h of x prime will be given as, now this is, what is the derivative of f of x? So now the derivative of f of x, so have it as f of x prime. That is the derivative of f of x. In this case, what is the derivative of g of x? We'll have it as g of x prime. That will be that. Then this is the derivative of the function h of x. Then we are looking for the h of x should be h of 4 prime. What is the h of 4 prime? So which means wherever there is x in the function, we're going to put 4. So in this case, we have 3 times, now have f of 4 prime plus 8 times g of 4 prime. That will be that. And what is that of, let me take this one out. Now what is that of f of 4 prime? We have it as 6. So we have 3 times 6, that will be given as 18. And what is g of 4 prime? We have it as -3, and times 8, that will be given as -24. So you can simplify that in that way. So that's how you should have to insert the derivatives there. Let's say the question part B, we need to have, let's say question part B, we have h of x, and are being given as f of x and the times g of x. So now how should we have this? In this case, we're going to use the product rule, of which this will be given as u, this will be given as v. So in order to have h of x prime, so have h of x prime, they're being given as, using the product of differentiation. Let's say this is u and this is the v, so which means we'll have u prime, that will be given as f of x prime, and the times g of x, then plus g of x prime, that is times f of x. That will be that. Then now we are looking for h of h of 4 prime. What will be that? Then we'll substitute what is f of, now wherever there is x, I'm going to put 4. Have f of 4 prime, or have g of 4 like that, plus g of 4 prime like that, times f of 4 prime. We'll have that. It should be just f of 4. Then we'll just have to substitute the values corresponding to that. Now we can have it as h of 4 prime will be given as, what is f of 4 prime? We have it as 6 times, and what is g of 4? We have it as 5, and plus what is g of 4 prime? We have it as -3. Should be -3, and the times what is f of 4? We have it as 2. So try to simplify that one, and you have it in that way. Now let's have question part C. Let's say we are looking for, let's say we have h of x, and basically they're being given as, let's say, f of x divided by, let's say, g of x. Now how should you have the derivative of h of x? So in this case, I'm going to use the quotient rule. Now h of x prime will be given as a quotient rule. We'll have u prime times v, that is f x prime times g of x, then minus v prime, that is given as g of x prime, and that times times that is f of x, and divide by g of x over to the power 2. That is the derivative of h of x using the quotient rule there. Then you just have to simply substitute how we can have it. So now in this case we're looking for h of 4 prime. So wherever there's x, I'm going to put 4, have f of 4 prime times g of 4 and minus g of 4 prime times f of 4, like that, and divide by g of 4 and over the power 2. We'll have that. Then we'll substitute the values and see how we can have it there. So that's how you should have to understand about the incitation of the differentiation rules. In the final equation part C should be the other. We should have let's say we have h of x being given as should be f of x divided by that is f of x and a plus that of g of x. So try to have that. I'm going to use we are going to use the quotient rule there. Just have to look at how you manage that up. Now let's say we have also this another case as well, and see how we can appreciate that. Let's say we have h of 2. Let's say we have h of 2. Let me have this h of 2, and let's say it's given as 4, and we have, let's say, h of 2 prime. Let's say it is given as should be negative 3. Now the question says that we should find derivative of h of x divided by x, and on the same case we should evaluate the value when x is equal to 2. So which means first thing we have to differentiate the function. Then the next we are going to simplify. We're going to substitute wherever there's x we're going to put 2. Just have to evaluate that one. So let's first of all try to differentiate this one. So now the derivative d over dx of h of x over x. Now in this case we are going to use the quotient rule of differentiation, where I'll have h of x prime times x, then minus what is the derivative of x, we have it as 1, and it times h of x, that divided by x squared. We'll have that. Then d over dx of h of x over x, like that, and when x is equal to, that is when x is equal to, that will be done, that will be equal to, now wherever there's x, we're going to put 2. That will be given as, now we have h of x prime. Let me have it proper here. So which means we have, we have it as h of 2 prime and times 2 here. That will be that times 2 minus h of 2, that divided by, that is 2 to the power 2. That will be that. So what is h of 2 prime? We have it as negative 3, like that, times 2. We have 4 here, and divide by 4. You can be able to simplify that one in that case. Let's say we also have this another case as well, how we can have that. Let's say we have a case, let's say f of x, should have it as, let's say f of 2 is given as, let's say 10, and let's say f of x prime should be a single prime is given as, let's say, x squared and the times f of x. Now the question says that we should evaluate f of should be f of 2 double prime. Now how should you have this? Now first thing, we'll have to find the second order derivative of this case. That will be done using the product rule. So f of x double prime will be given as, now since we have this as the first derivative, and had it been that this one is not the first derivative, let's say it was just a typical function, it means we could have just had to differentiate once then twice in order to accomplish that one. So now since we already have the first derivative, then we just have to go for the second derivative. Now in this case, we're going to use the product rule. That will be given as 2x times f of x, like that, plus, plus should be x squared times f of x prime, and that is according to the product rule. Then we need to understand that we're looking for f of 2 double prime. That is to say, wherever there is x, we're going to put 2. And what will be that? So in this case, we'll have times 2 here, we'll have times 2 here, and f of 2 like that, and the plus, 2 to the power 2, and the times f of 2 to the power, actually f of 2 prime. That is, but now what is f of 2? We have f of 2 being given as, then how about f of 2 a single prime? So f of 2 single prime will be evaluated upon substituting in this case. So which means we'll have 2 to the power 2 times f of 2 there, of which f of 2 we have it as 10, and times 4 we'll have it as a 40 here. Since this one is the same as this is 4, we'll have it as that. That will be substituted here, 40, that will be that, and now we have this as 10, this is that. Then you'll be able to simplify that one in that case. So that's how you should have to understand about the principles behind the incitation of the differentiation laws. And also try to understand this one as well and see how we can have it. Let's say we have f of, let's say, a pi over 3 is given as, let's say, should be 4. And also let's say f of, let's say, pi over 3 prime, it says given as -2. Let's say that is the case, and they're assuming that g of x is given as, let's say, should be f of x and that times sine x, and also we have h of x, and also we have h of x, let me have it in this end, and also we have h of x, and basically being given as, let's say, cos x, and that divided by, and that should be f of x. Now the question says that find, let's say, g of pi over 3 prime. Now how should you have this? First thing, we'll have to differentiate the function of g of x. So in this case, I'm going to use the product rule, as you can see. So which means we'll have g of x prime, that will be given as, f of x prime times the sine x, times sine x, and the plus we'll have f of x times cos x, and that should be times cos x times cos x, like that. Then now we are looking for g of, should be g of pi over 3 prime. So which means we'll have to substitute That is to say, g of pi over 3 prime is equal to wherever there's x are going to put pi over 3. So which means f of pi over 3, we have that a prime, by the way, and the sign, pi over 3 will have that, and a plus, f of pi over 3 like that, and the times cos pi over 3. Then we'll have that. Thereafter, we'll have to substitute the given values in the question. Now, what are the given values in the question? With respect to what I have obtained here. So what is f of pi over 3? We have it as 4. Like that times. What is sine pi over 3? Mind you, pi over 3 is 60. It's 360. It should be actually it's 60 degrees. So what is sine 60 degrees? We have it as a square root of 3. Divided by 2. And the plus, what is, by the way, this is for the prime case. What is f of pi over 3 prime? No, we have it as negative 2 here. In the times, what is sine pi over 3? We have it as square root of 3 over 2. And the plus, what is f of pi over 3? We have it as 4. Times, what is cos pi over 3? We have it as 1 over 2. That is that. Then we can simplify this one in that case. So that's how you should have to understand about how we can be able to incite the differentiation laws for this case. And also at your own time, try to have, let's say, the question part B of the case, where now we are looking for h of pi over 3 prime. Now how should you have this? That is the point of interest. And let's say if we have, let's say, this case as well. Let's say we have the function, let's say f of x. That is for a calculator. It is given as f of g of x. That should be that. Let's say f of g of x and like that. Should be, this f is the small letter, by the way, and we have been given that f of, let's say, negative 2 is given as, what is f of negative 2? We have it as 8. And we have f of, let's say, negative 2 prime, we have it as that of 4. And let's say f of 5 prime, and say we have it as 3. And we have also been given g of 5, let's say it is negative 2. And also in the same case we have g of 5 a prime, and let's say it is given as, that has to be 6. Now what is f of 5 prime? How should you have this? So this is the function of interest, where we'll have to differentiate the function f of x. Now we should have to view what we have here. As you can see, we have the function which is corresponding to f, and we have the inner function which is g of x. So which means we have the outer function which is the whole of this one, and we have the inner function which is given as that. So we're going to differentiate that and using the chain rule. So f of x prime will be given as, now what is the derivative of the outer function? we'll have small letter f times g of times g of x prime times the derivative of the inner function. What is the inner function? G of x prime. We'll have that. Then I'm going to substitute that, and in the sense that we'll have it as we're looking for f of 5 prime. So what is that one? We have small letter f, and here times what is now we have g of 5, that is, and prime times we have g of 5 prime. That, and what will be that? Then it is the matter of substitutions there, and let's see how we can wake it up. So a capital letter f of 5 prime, so f of 5 prime will be given as now small letter f times what is g of 5. G of 5, it is given as -2. We have -2 prime like that times what is g of 5 prime. We have it as, that has to be 6, so we have times 6 here. But what is f of 2 negative prime? Should be f of 2 -2 prime. Now we have it as 4. We'll have 4 here. We'll have 4 times 6. That will give us what we're looking for. So keep that in mind. Now how about, let's say, if we have this case. Let's say we have another case like this. Let's say we have h of x is given as has to be, let's say, a square root of, should be 4 plus, and that is 3 times f of x. Let's say that is the case, and we have f of 1 being given as should be 7, and we have f of 1 prime, let's say it is given as 4. Now what is the value of h of 1 prime if this is the case? So we are going to differentiate this one using the chain of differentiation, in the sense that h of x prime will be given as, we'll have to write this one, we'll have the overall power as the half using the laws of indices. So so now using the chain we'll have half times the inner function, that is 3xf f of x to the power -half, and times the derivative of the inner function. So what is the derivative of the inner function? We have it as a 3 f of x prime. We'll have that. Then just the matter of substituting the given cases there, of which we are looking for h of 1 prime. Wherever there is x, I'm going to put actually 1. We'll have 4 plus 3 f of 1 to the power -half. You know what it means there? Then we'll have times 3 should be times 3 times f of 1 prime. Then we'll have to substitute the given information and see how we can be able to work it out there. Now how about, let's say, if we have this case. Let's say if we have f of pi over 3 and is equal to 4, and also let's say we have f of pi over 3 should be pi over 3 prime. let's say it is given as should be -2. Let's say that is the case, and of which we have g of x, and say it is given as, let's say, f of x, let's say cos x, like that. And we have, let's say, h of x, and let's say has to be given as should be sec x, should be sec x, like that, and the divide by should be f of x. Let's say that is the case. Now we should have to find what is a g of, pi over 3 prime, like that, and also we should have to evaluate what is h of pi over 3 prime if this is the case. So try to have that and see how we can have it there. And let's say we have the following problems as well, and I should have to deal with these cases at your own time. But before I go further, let me have to choose something. If we have, let's say, f of x, and let's say to the power, let's say 2. Now, in this case, the derivative of this one will be done using the chain of differentiation, where you have 2 and f of x as the inner function, and 2 minus 1, that will be given as 1 times the derivative of the inner function, that is f of x prime. We have that. Let's say if we have f of x to the power 3, like that, then the derivative of this function will be done using the chain as well. Outer function f of x to the power 3 prime times the derivative of the inner function, which is given as 3x squared. We'll have that. That is for some cases. Let's say if we have h of, let's say, x squared, let's say in that way, in terms, let's say, f of x in this case. So now what is the derivative of this one? We also use the chain as well, in the sense that we'll have the derivative of the order function, which is given as h of x squared, f of x, a prime, and it times the derivative of the inner function, which is given as this, of which we use the product rule to differentiate the inner function. So that is just a part of a typical tip that you should have to also bear in mind about. And for some cases, let's say we have r of x, let's say it is given as f of g, this should be that, of h of x. Let's say that is the case. Let's say that is the case, and of which we have h of 1 being given as, let's say we have it as 2, and we have g of 2, let's say it is given as should be 3, and we have h of 1 prime, that will be given as 4, like that, and we have g of 2 prime, we'll have it as g of 2 prime, let's say it is given as 5, like that, and we have f of 3 prime, let's say it is given as 6. Now find what is fr of 1 prime. So try to have that if that is the case, and also think about this one as well, how we can handle this. Let's say we have f of x, and which is given as f of, let's say, 3, and f of let's say f of 4, like that. And now we have, let's say, another f of, let's say, f of x, like this. Let's say that is the case. And on the same case, we have f of 0. Let's say it is giving us 0 as well. And f of 0 prime, it is giving us 2. Now find what is cap greater f of 0 prime, if that is the case. So try to understand how you can have it there. And also at your own time, try to think about how we can handle this. Let's say we have the cap greater f of x, and being given as, f, should be the small letter, by the way, small letter f x, fx, let's say like that. And now where f of 1 is given as, let's say, 2, and now we have f of 2, and now we have f of 2, let's say it is given as 3, and that should be that. And f of 1 prime, it is given as 4, and f of, let's say, 2 f prime should be given as 5, should be given as, it has to be 5. Now, and also we have f of 3 prime, and that also is given as, let's say, 6. Now find what is the cap greater f of 1 prime, if this is the case. So that's how you have to understand about the incitation of the differentiation laws. Thank you.